Well, this is Go Magic. We're learning things together. It's magical. We're going to do question 12. And it is a moment question. No way. Question 12. You have a diagram that looks like this. You have a long rod, 1.5 meters long, and it is uniform. Means our center of mass of gravity is located exactly at the center. And the weight of 2.4 newtons, so exactly at the center, weight is equal to 2.4 newtons. So this one should be 0.75 meters. The rod is supported on a pin passing through a hole in the center. Ropes A and B provide equal and opposite forces. So you have a force here, we call it force A, and you have a force here, we call it force B. Equal and opposite, 8 newtons. 8 newtons means we have a couple. If we have a couple, means we can calculate a torque. So, 1. Calculate the torque on the rod produced by ropes A and B. So, direct question for 1 mark, quite easy. So, torque is equal to 1 force times perpendicular distance between two forces. Remember the difference between moments, where it must be a force and a pivot. Here is two forces. One force here is 8 newtons times the perpendicular distance apart. In this case, it's 1.5 meters. I'll allow you to calculate that, and hopefully you get an answer of around 12 newton meters. Moving on to question 2, describe briefly whether the rod is in equilibrium. So discuss. Is this in equilibrium? Meaning, is it stationary? For 2 marks. So, in order for equilibrium, 2 things might exist. No resultant force in any direction, or and no resultant torque about any point. But here, remember, you have a torque, means that you will now have a turning effect. Once you have a turning effect, therefore it's definitely not in equilibrium. So, your answer is there is a resultant torque. Therefore, the rod rotates and is not in equilibrium. Now, moving on to the next part, B. Notice, very straightforward, very easy questions. The rod and A is removed from the pin and supported by ropes A and B as shown in the figure. Rope A is now at a point P, 0.30 meters from one end of the rope, and rope B is at the other end. So we replace the pivot. Just now the pivot is at the center. Now we change the pivot at a different location. So we draw the same thing. And then you have rope A, force A at 0.30 meters. Weight is 2.4 newtons at a distance of 0.75 newtons. So apologies, distance units is meters, because overall this one is 1.5 meters. So half of it is 0.75 because it's a uniform rod. And you got force position at B. And again, reminder, our pivot is now, it's not pivot, it's just where the force is, okay? So the pin is removed, and then we got something like this. A, calculate the tension in rope B. Now, key point here we need to know is whether this object is moving or not. So let's read again. The rod in A is removed from the pin and supported by ropes pin is removed and this is the rod is supported by the two ropes. Okay, notice the ropes are in this direction, similar to the question we did previously in the previous videos. It's no longer having a turning effect. Notice again the difference. No more pivot, weight still stays the same because we're dealing with uniform rod, but we got two forces now, both in the same direction. We no longer couple, therefore we can say supported means this is a stationary object. Once you have a stationary object, means we can use the principle of moments. The question asks us to calculate the tension in rope B. We have to find rope B. Okay, so let's begin. Let's choose a pivot P to be this end. So, using principle of moments, remember please write this in full so that examiners know what we're using. I just guided you, so I just write it in short form. You have anti-clockwise moments, show the direction, is equal to sigma clockwise moments, show the direction. So pivot is here, we start with this FA. FA is in this direction, but we have a problem here. If you want to find FB, if we put FA here, which is an unknown, we're going to have a pretty messy way. So we have to change our pivot. We got two variables, FA and FB, so we need to eliminate one variable. To eliminate one variable, I'm going to put the pivot at rope A. When you put a pivot at a force, that force therefore does not create any moment anymore. There will be no moment at that particular point. So P is now at A, that means FA does not have, point A doesn't have any moments. So, using principle of moments, about rope A. There you go, that make it easier. This doesn't exist anymore. This is now the new pivot. Means we need to calculate what is this. 1.5, 0.3, this is 1.2 meters. So, new pivot. We got weight going this direction, is clockwise. So we have 2.4 newtons. We have to find the distance here. So this is 0.75, this is 0.3. Therefore, this should be 0.45 meters. So 0.45 meters. Then we got this one moving in the opposite direction in the anti-clockwise moment. It will be FB, and the distance here will be 1.2. How do you know if you use principle of moments? You've got two forces. One is in one direction, the other one is in the opposite direction. So they can balance off each other. So with that, hopefully you'll be able to get a value of around FB is equal to 0.90 meters. When it comes to this, please don't leave it like this. Please make it subject to avoid any calculated error. Meaning you just type something wrong, just put it like this, and hopefully you get this value. Okay? Remember I don't calculator, so hopefully you get that value. Like I said that this and this cancel out. This will be 1, 2, 2 times 0.5, yeah, 0.90. So hopefully this is the correct answer. Now moving on to the next one, 2. Calculate the tension in rope A. Now you want to find what is FA. There are two ways to do that. You can repeat what we've done using principle of moments, or you can use the point mass diagram. Because the object is stationary, if you were to draw this, it would look like this. You got FA balanced by FB, two up direction, and you got weight down. That means, remember again, it's stationary. Choose upwards to be positive. So resultant force is equal to Fa, because upwards forces is balanced by weight, therefore it doesn't move, means this is equal to 0. We have positive Fa, direction we chosen, plus positive Fb. W is the opposite direction, minus W equal to 0. Therefore, we want to find Fa. So Fa is equal to W, positive W, minus Fb. W is in this case 2.4 newtons minus 0.90 newtons is equal to a value of around 1.5 newtons. Remember again, physics, there's a lot of ways to do it. Just make sure your equations are physically correct. And you can use physical moments, but here we can actually use forces. Remember again, because object is stationary. Okay? You must always check that your equation matches, if you can, have a diagram and the physics is correct. Once it's correct, the question that looks visibly complicated becomes something that is very straightforward. I hope you understand this video. If not, please play this video and provide me with some feedback.